Hello everyone, thank you for the introduction. As mentioned, I'm the president of Open Space Makers, and Open Space Makers is developing the Féderation initiative. What's the Féderation initiative? Basically, three things to present it. First, it's an initiative that was launched by the CNES, the French Space Agency, 4 years ago. It aims at opening up the world of space to everyone, so enabling anyone who's willing to spend time and energy on making and designing space infrastructure and giving anyone the means to do that. And so within Open Space Makers, Féderation Open Space Makers, we have volunteers. It's an all-volunteers non-profit association who are developing and manufacturing, building space infrastructure. One key item which is at the base of all these projects is that they are open source projects. That's both to protect the work of volunteers, but also to enable to go to the next stage of space innovation, to enable anyone to benefit from the failures as well as the successes of all the projects that are developed within Féderation. In practice, how are we doing that? First, we have 4 key pillars to develop the activity of Féderation. The first one is a Féderation Charter. This Féderation Charter is basically stating our key values, including collaboration, openness, and open source is embedded in this charter, as well as responsibility. We have some things about export controls, about pyrotechnics and so on, which is key, and also about benevolence, actually, inside this Féderation Charter. The second part is a collaborative web platform, so we have both communication to enable both communication between members and as well as collaborative work, so project management tools and so on available online. Typically, you may be the only person in your village to be interested in working on an orbital telescope, but there may be someone else in a village at the other part of France or of the world who's interested in working with you. And so through the collaborative web platform, you're going to be able to build your orbital telescope together. The third key pillar is a network between not only individuals, but also collaborative workshops, fab labs, makerspace, hackerspaces, where the designs that are prepared online by the teams can be actually prototyped and tested in real life. And the last but not least fourth pillar of the initiative is direct support to projects. So we, of course, when you're talking about making actual hardware, you need resources, and the association is providing material, financial, as well as skill support to enable the project to happen. I've mentioned fab labs, hackerspaces, makerspaces. You may not be familiar with them. Some examples here. Basically, these are collaborative workshops which are usually managed in an associative way, and which are basically, you're going to be able to find machinery, tooling to do electronics, mechanics, chemistry, of course, additive manufacturing, and so on. So it's really and located anywhere, well, in most cities, towns in France and anywhere in the world. So what would you expect in terms of space hardware to come out of these kind of workshops with volunteers contributing on their spare time? Well, one of the first projects we had in Féderation is an electrical rocket stage separation system, which you can see here. So this system was basically designed at the beginning for a mini rocket or an experimental rocket. You can see a test, an in-flight test, which was performed on a mini rocket on the right. And actually, the way it worked, it was developed in one fab lab. The design was improved in another fab lab by another team, and now a third version is being developed, a bit scaled up to go in an experimental rocket, which will be tested later this year. And that's the iterative principle of Féderation projects. Actually, we have a lot of projects which are related to rocket subsystems, and we have one big rocket project within Féderation, which is called Adastra, and they aim at building a fully reusable micro-launcher. And so going through and you've understood now, a lot of iterations, so testing bigger each time, scaling up the systems which were testing beforehand. And so aiming in a certain number of years at going orbital. As part of the convention and the partnership that Open Space Makers has with CNES, we are working with ArianeWorks on several bits of THEMIS. You know that THEMIS is a demonstrator for a reusable first stage to be used on Ariane Next, so the replacement to Ariane 6, and some bricks, some subsystems of THEMIS were opened in the collaboration with Féderation. One example of this system is the Pelican Bay. So Pelican Bay is a modular bay to deploy a payload in microgravity for a suborbital flight, because THEMIS will do for some suborbital flights before going orbital. And so here you can see the way it works. Basically, the ArianeWorks team provided some specifications for this subsystem, which is a non-critical, let's say, nice-to-have system for THEMIS. A team within Féderation got together to work on some design, and there were 4 or 5 different candidate designs transformed into CADs. And then one of the most promising of this design was turned into a working prototype, which we will be able to see on our booth outside. And so that's the basic idea, and of course, the prototype itself is being used to improve the CAD and going to the next stage beyond that. Another example of subsystem that's developed still in the partnership with ArianeWorks, you may know about the Smart Catcher system to catch the first stage of a rocket, which is landing on the ground after launch. And so the same thing here, to have the system to catch itself, to catch the rocket, was opened in THEMIS Open, and as you see CAD designs, and going from the CAD design to actual prototype to test. And you can also see on our booth a small scale version of this system. I've talked a lot about rockets, but we're also looking at much beyond the Earth orbit, or going to Earth orbit in Féderation. One project example is Mars-Proof. Mars-Proof is an in-situ resource utilization project for Mars. So basically turning the Martian soil and Martian atmosphere into the necessary components for human base on Mars. And so based on a lot of course, documentation and existing works, the team is working on several bricks and demonstrators for several bricks for this IS3 project. And so you can see here, in part through a partnership with an engineering school in the Paris area, designs which are produced collaboratively between the member of the team as well as the students in the school. So for example here, a chassis and an oven, a chassis for a rover to convey the regolith from where the place it is extracted to the place it will be handled. And then on the bottom, an oven to heat the regolith and extract its water and then condensate it. We also have projects which are between Mars and going to orbit. We have projects in orbit. An example of this is Phoenix. Phoenix is an orbital IT cloud, so a computer, and basically we aim at putting compute and storage capacity in orbit. It's going to be an heterogeneous constellation. When you think constellation, we often think a constellation of homogeneous satellites at very similar and going at the same orbit to deliver a given service. Here we are developing an open standard to access compute and storage capacity in orbit to make treatments for example, radio processing or image processing in orbit. And we are still going very small step per small step, and now working on a ground version of it, developing the standards, the web user interface, and so on the ground, and planning to go orbital in 2 years from now with the first CubeSat demonstrator, which will extend this system built on the ground to space. One very last example of projects, I'm sure now you've understood a bit the way we work and we proceed. The last example is, you may have heard about the R&D challenge that the CNES launched in March in order to solicit input on how to reuse a upper stage of a rocket. Within Féderation, there was a team which got together in several days of interested and passionate people who wanted to submit a concept, and so in 3 weeks they were able to propose this concept, which is called Project Boomerang. So 8 persons worked on it in their night, in their weekends, on their spare time, to propose the Project Boomerang, which you can see here. So basically you have an inflatable heat shield as well as a toroidal bilute, which is slowing down the re-entry. And afterwards you have a parachute which goes out. The great thing was they got selected by the CNES to pitch their project, so alongside startups, alongside large industry groups, and as association and volunteers, they got to pitch it, and they were selected to receive a contract to further develop their concept over the coming year. So it was let's say, a vindication of the way Féderation can make out of a volunteer contribution, working in a very decentralized way, and being able to propose concepts which are actually seen as of value to the space industry. So now, last thing, and one of the things I'm here for, I'm addressing myself to all companies which are represented in this room. So I encourage you to join Féderation. You've seen some example of what can be achieved in Féderation. So a free proposal to join Féderation. You could propose projects which are upstream or downstream of your core businesses. And as I mentioned, they are open source, that's why downstream or upstream or downstream. The second thing could be to launch challenges on spaces or blank spaces of your sector, so to generate innovative designs for medium to long term of your sector. And third thing, if there are projects which are already existing which could interest your organization, support them if they have a link to your core business. And lastly, of course, I'm not addressing only you as the organizations you represent, but also as all the individuals in this room. And we encourage you to join Féderation as individual. You've understood it's free. Just what we ask is for your time and energy, not your money. And so just to join us, go to fosm.space or come to meet us on our booth outside. We'll be very glad to exchange with you. Thank you for your attention, and I hope you're now pumped up to open space with us.
Thank you, Damien. We have a few minutes for questions, if anybody has anything burning. If not, as you mentioned, you're also outside the booth, and I think also everybody needs a bit of a pickup coffee. A question from myself, Damien, is how do we join the Féderation? You've mentioned that we just go on the website and assign.
Exactly. So there's a catch. Once you get to the platform, you can click on register. And when you register, you have in red that when you register, you become a member of the association. So you accept the Féderation charter, and so you become a member of the Open Space Makers Association. So you just have to sign up online. So no prerequisite. Wherever you live, you can join us.
That sounds great. And just for our international audience as well, is the Féderation only based in France, or are you working with other international chapters?
Currently, we are only based in France, so it was founded 4 years ago in France. But we are actively looking at actually creating sister associations elsewhere in the world. So we are looking forward to the day where we have, I think it's 195 Open Space Makers Association. So going from Open Space Makers Italia to Open Space Makers China or Argentina.
That's a great pitch. And for those of you streaming with us, live streaming with us from around the world, that's a good invitation to contact your organizations, perhaps on social media or directly through us. We'll direct everybody to you. Now it's coffee time, and coffee's ready for you at the first floor. Thank you once again, Damien. I'll see you during the break.